Okay, so right now I'm doing question number 14 on the first homework assignment. The question asks, find dp dq for the following function where p equals 4q sine q over q squared minus 5. So I did some of the workout already, so obviously this is a chain rule. We have two parts. We have the u part, which is the 4q sine q, and then we have the v part, which is the q squared minus 5. So, well, it's actually 1 over q squared minus 5, so that's actually an important thing to note. So let me just add that really quickly. So, yep. Anyways, so I already took the derivative of these because these are pretty trivial derivatives. The derivative of u is using the product rule, which is u v prime plus u prime v of f of x. If this is f of x of u, this function here, then we take 4 times q times sine of q, and because the derivative of q is 1, it's just sine q times 4. So that's the first part, and then u prime of u times v is just the derivative of sine q, which is cosine of q times 4. So that's u prime. Pretty much the same thing happened here. One important thing to note is that we can rewrite v as q squared minus 5 to the minus 1 power. So that's essentially what I did. So I used a chain rule in order to figure that out, where f of g of x, the derivative of that is f of x times f prime of x times g prime of x. Yep. So, anyway. Okay, so we did the main parts, and now all we have to do is construct the function 4q sine q, q squared minus 5. We have all the parts in order to solve f of p in this case. So f of p, or actually find f prime of p. We're trying to find the derivative of it. So f prime of p. So we're just going to quickly construct the parts, and we get u v prime. So we're going to say, let's just add this really together really quickly. We get minus 8 q squared sine q divided by q squared minus 5 all squared. Okay, so that's the first part. Second part, we're going to take the u prime times v and add it together. So u prime equals 4q cosine q plus 4 sine of q. Good. Okay, so and then that's times all times v, which is just q squared over minus 5. So okay, so we could just leave this essentially as the derivative if we really wanted to, but we're going to simplify it further in order to satisfy the answer of this question, even though it's already technically correct. We see in the denominator that this side has q squared minus 5 all squared, and this one's just q squared minus 5, so we're going to stick all of these under the same denominator, which is essentially just multiplying this part by q squared minus 5, or divided by q squared minus 5, so we'll get the same denominator. So what we're going to do really quickly is just multiply that by q squared minus 5, and we're going to get 4q cubed cosine of q plus 4 4q squared 4q squared sine of q minus 20q cosine q minus 20 sine q. 20 sine q. Anyway, okay, so now that these are all in the same denominator, we can just add them together. So I'm just going to say 4aq sine of q and q squared minus 5 all squared. Okay, so we're just going to add this together. We see 4q, oops, forgot to put the squared here. It's my fault. You can see it there. 4q minus 8q squared sine q. There are two of these terms, so we're just going to add them together. We're going to get minus 4q squared sine q. And then all the other terms are just the same as right here, so we don't need to write them out because this is just a multiple choice question. We can just look at the answers directly from here, and we can see that it's D 4q cubed cosine q. We have it right there. Minus 20q cosine q right here. Minus 20 sine q right here. Minus sign's there if you can't see it. And then minus 4q squared sine q, which we just figured out just by adding those terms together. So that's the answer.